Hi there, and welcome to another video from the Maths Coach. We are on calculus in this video, and this is the application part of calculus. We are given here a cylinder with height 2x centimeters. Please take note of the units that are used here. The radius is r centimeters. It is placed inside a sphere with a radius of 9 centimeters. So now a sphere is a ball, right? Okay. So that means if we've got a radius, that means then this is the central point of the ball. Okay, so this dot here is actually the central point of the ball. Now, they have kind of given you a clue on how to go about this problem, even without reading the first question. I will get to the questions, but if you just look at this diagram, a few things should kind of come up to mind as far as this diagram is concerned. For example, if this is the height, and we know that thing is the center point, which will also be the center of this cylinder inside the sphere, then that means this portion here should be x. And where do I get the x? It is half of 2x, the actual height of the cylinder. So that should actually now then tell you that you're going to have a right angle there, and you could then use the theorem of Pythagoras to find the radius in terms of x. Okay, once you have done that, I guess we could anticipate a question perhaps on surface area or a question on volume of either of the sphere or of the cylinder inside the sphere. Let us have a look at the questions and see exactly what they are expecting. The question goes, we have to show the volume, we have to show that the volume of the cylinder, Vx, so expressed in terms of x, is 162 pi x minus 2 pi x cubed. Now, I know there's a point where someone would say maths papers are unfair. They teach you in class how to calculate distance between two objects, and then in the exam, they ask you to calculate the distance between the sun and the moon, right? So it's not that, it's not really rocket science. Let us just go back to what we know, okay, basics. How do you calculate the volume of a cylinder? Well, for any 3D object, the volume is always equal to the area of the base times the perpendicular height. That is the height which is perpendicular to the base. What is our base in this case? It is a circle. And from grade 8 to 9, we should know that the area of a circle is pi r squared. The height is given, it is 2x. That means then the volume of a cylinder in this case, it will be pi r squared times the 2x. If you like, you can simplify this and write it as 2 pi x times r squared. We cannot have two unknown variables. We always want to avoid this situation when it comes to the application of calculus, because we're going to find derivatives. So we would rather be clear as to which letter we're going to use. And they have given us a hint. We clearly want to get rid of the r, so we want to have everything in terms of x. Now, going back to the previous analysis that I made, we know that this side here is x, and this is actually a right angle triangle. So I will use Pythag to find the radius in terms of x. So if I use Pythag, I know that 9 squared is equal to x squared plus r squared. And then this will then become 81 minus x squared is equal to r squared. Now, I will not stress myself by taking the square root to find r, because I actually need the value or an expression for r squared. So I will substitute 81 minus x squared in the place of r. And in this case, I'll have 2 pi x times 81 minus x squared. And multiply out. I guess now we see where the 162 comes from. 162 pi x minus 2 pi x cubed. And this is exactly what I was required to prove. I must say, you will not always get a question on volume, okay? It could be about the minimum distance between two functions. It could be about motion of an object. It could be on area and perimeter. It could be on total surface area again. There are varying questions around this. So that the more papers you do, then the better exposure you will have, and the better than the chances are of you getting this section correct. I hope you do see it's 8 marks. It can be a lot. It can be the difference between that distinction that you are looking for, or that pass that you are hoping for. So please do try and practice this. Now that we have shown this, we can answer the following question. Calculate the value of x for which the volume of the cylinder will be maximum. Now, we know that from maximum or minimum, we have to find the first derivative. And I think we have established this from our cubic functions. So we will find that then by finding the first derivative of Vx. And in this case, I need to take note that everything else that is not an x is actually treated as a constant. So this will be 162 pi minus 6 pi x squared. So that is my derivative, right? And then if I continue, I will then have the following. I have to set this to 0. That's where we find the maximum. And I'll have 162 pi minus 6 pi x squared. And I can guess how they're going to allocate your marks here. For finding the derivative correctly, for equating the derivative to 0, in other words, you are showing that you understand what you have to do when you find the maximum or the minimum. That is actually a mark. Now, all we have to do now is to find the value of x. So I'll have 6 pi x squared is equal to 162 pi, and I will divide pi both sides, and I'll divide by 6 both sides, and I will go to my calculator here. 162 divided by 6, that should give me a 27, which means that x is plus minus square root of 27, which can actually be simplified to 3 square root 3, because 9 is a perfect square, right? And obviously, because we're talking volume here, we don't expect a negative measure, so we will actually take the positive square root 3 root 3 there. Okay. Positive 3 root 3, apologies there. And then, yeah, just like that, we have calculated the value, and so your third mark will come from that. The next thing that we'll then do to calculate the maximum volume of the container, and I'll leave this one to you. You can see it's easy to note. You will substitute this x value where into the original function Vx. So here's Vx. We have calculated the x value that gives us the maximum. Now to get the actual maximum, you have to substitute this value right in there. And you will round off to two correct 2 decimal digits. That is one of the standard instructions that come with your final paper. So go ahead, give it a try, see if you can actually do this on your own. Remember to hit that bell for notifications for any new video that I may be uploading. And also feel free to ask a question. The WhatsApp number is on the description. Make sure that you also get assistance in preparation for your final examinations or your prep, your test, whatever assessment you may be facing. Please don't be shy to ask for help.